Hello, Professor and everyone. Before present about my term project, I want to talk about my problem. In the past presentation, I want to build an observer for UR5 robot to detect collisions. And you can see I complete the simulating model in MATLAB here. However, I meet a trouble. Uh, this is the code. I calculate the matrix for UR5 manipulator. I paste on this paper. Uh, this paper I show in the past presentation. Um, However, here you can see this is the inertial mass matrix for your 5 millimeter, and this is the centrifugal matrix. Uh, I calculate following the paper. Mm, However, you can see the mass matrix of UR5 6-degree manipulator is very complicated expressions here. Uh, so my simulating model has failed when running. I think I need more time to solve this matter. Um, at last, I decide to change the topic into position estimation for robot actuator based on Kalman filter. Robot actuators were originally designed to be used in overloop control. Their inherent stepping ability allows for accurate positioning without feedback. However, they show a poor performance with respect to very precise motion control and high dynamic requirements. Closed-loop control with the additional position sensor improves on their difficulties, but the final solution becomes significantly more expensive. In additional, with encoder system, calculating the velocity from feedback positions by V will cause a large error. Therefore, sensorless control of stepper motors emerged as an alternative and attractive solution since it saves the expensive and peculiar mechanical sensor. The inputs of most position estimators are current feedback and voltage control signal, which are usually affected by noise. In the real system, the current feedback consists of measurement noise caused by non-ideal ADC, analog to digital converter. And this report is mainly focused on position control of hybrid stepper motor without using an encoder. The Kalman filter is used to estimate the state of the system and reduce the influence of measurement noise and system noise. Here is the mathematical model of a motor. It represents in state space domains as follows the equation 1, where omega is the mechanical speed of the rotor shaft, Theta is the rotor shaft position. G is the moment of inertia of the motor. P is the viscous friction coefficient. And T is the electromagnetic motor torque. The electrical equation of motor is considered as the equation 2, where IA, IP, and UA, UB are the currents and voltage with the corresponding phase of A and B. R is the phase resistance and L is the phase inductance of phase winding. And define a step vector include the current, positions, and velocity from equation 1 and equation 2. The continuous model in the state space is represented by following equation 3. And matrix A, P, and C I list here. Equation 5 is the discrete form of equation 3, and here is the matrix AD, BD, and CD. And now we need to consider about the influence of measurement noise and system noise. We add noise into the discrete model phi, and the noise can be represented as a Gaussian noise. I refer the book title here. Apply optimal estimation from the MIT Press, 1974, to have the algorithm of Kalman filter can be presented by initial value testing, state vector, and covariance prediction, Kalman gain calculations, state corrections, covariance matrix corrections. And this is the part for simulation result. To demonstrate the performance of Kalman filter, I built the whole system in MATLAB Simulink. The table 1 showing the parameters of hybrid stepper motor, and figure 1 showing the model in MATLAB Simulink. You can find the MATLAB Simulink code in the Google Drive I add below. And figure 2 showing the reserves and estimated rotor resistance and velocity. You can see the result is good. The reserved position and the Kalman filter estimate positions is similar, and the right picture is showing the reserved velocity and Kalman filter estimate velocity. It also fit. And figure 3 and figure 4 showing the activator feedback and estimate current phase A and B. The blue regions showing the noise of current phase A and B, and the red line shows the noise is reduced by Kalman filter. And here is the MATLAB code in Kalman filter. I also add in the Google Drive. And if you have any questions, please tell me, and thank you for listening.